Now, as you can see on the screen, there is a graph for the explanation of this. Now, on your this axis, there is energy, correct? And here there is intermolecular distance, or we can say a bond length. Now, as you can see on the screen, this is a zero, indication of zero, correct? Zero energy. Now, as the two atoms, now here we are talking about hydrogen molecule. What is hydrogen molecule? That is your H2, correct? So here on the extreme right side, you can see two hydrogen molecules are placed, or two hydrogen atoms are placed, and they are placed far away from each other, correct? Hence, when they are far away from each other, that means what? The energy is little bit more, correct? And the molecular intermolecular distance is also high, correct? But when they are very close to each other, that is also not ideal. Here, what is there? Here the repulsive force is high, and hence they are not coming together. Here attractive force is very too muchly high, correct? Hence they are very close to each other, which is also not ideal, because there is increase in the energy. But when you see here, there is a point here, look here on the screen, in the graph there is a point when your attractive energy is little bit more than your repulsive energy. So at that time there is a bond formation, and that is what we are going to look over here. As you can see, after a point, if the atoms approach any closer, the repulsive force between them will increase and stability will decrease. I hope this is clear to you now. Let's move ahead. Now, when we talk about bond length, now this is the actual definition of bond length. When we say bond length in layman language, we say that the distance between two atoms. But what is it actually? So the minimum distance between the atoms of two elements, now this is important, beyond which the repulsive forces will become greater than attractive forces are called bond length. I hope this is clear now. I hope you will not just say, when someone will ask you what is bond length, please just do not say the distance between two atoms. It is not true. It is also required in the terms of energy, correct? Now let's go ahead. Now we have seen that when there is a bond formation, there is a stability, correct? So when we talk about stability, which is the most stable element in the periodic table, or let's say which are the most stable elements in the periodic table, correct? You know that the group 18 elements, that are your noble gases, correct? Those are your most stable electronic configuration and most stable elements. So now this is the criteria behind bond formation, that the bond formation takes place to achieve the noble gas configuration. So when we talk about noble gases or group 18 elements, what are your group 18 elements? Now as you can see on your screen, the group 18 elements are nothing but your helium, correct? Then your neon, then your argon, then your krypton, and then your xenon. Now, where are they placed in the periodic table? Now, what is your periodic table blocks? You have S block, you have P block, you have D block, and you have F block, correct? So they are placed somewhere in the P block, you know that, correct? So when I talk about P block, your P block starts from boron, and after that carbon, then after that nitrogen, after that oxygen, and after that fluorine, and after that your neon, which is your noble gas, correct? So this element or this group in the periodic table are noble gas elements and group 18. So all your bond formation takes place in order to achieve the noble gas configuration. Now what is noble gas configuration? Let's look at that. So inert gases, they are also called as inert gases. I hope you know that. So inert gases have complete octets with ns2 np6. Now why np6? Now why p orbital? Because the last electron is entering in the p orbital, correct? So the electronic configuration of noble gas elements are ns2 np6. N is your quantum number, or let's say principal quantum number. So inert gases have complete octets that just we have seen with NS2 NP6 configuration, and thus they are very stable and they do not form bonds. You do not see your noble gas element forming bonds because all the shell of their electrons and all the shells are completely filled, and the noble gas elements hence they are stable. Now let's move ahead. Now all the other elements, correct, apart from noble gases we are talking now, all the other elements obviously their shells are not complete. They do not have complete octet, correct? So they will take part in the bond formation. So all the other elements participate in bond formation. Now how the bond formation will take place? Obviously by gaining, losing or sharing electron to achieve the complete octet. So in order to achieve octet, your atoms or elements will share electron, will donate electron or will gain electron.